Okay, so linear approximation or linearization. So it's called both, okay, either linearization or linear approximation. It's what happens when we approximate the answer. So what I mean is, I'm going to show you an example of, so let's say we want something like this, okay? So we're looking for the y value at 3.111. So what you would do is you would take the function and then you would plug in 3.111. But that would probably take a calculator, because if you plug it into something like negative 2x squared plus 5x minus 7, you're not going to do that by hand, right? So if you don't have a calculator, what we can do is linear approximation. So what we do is we don't just use the y value at 3. What we do is we find a tangent line at 3, and then we plug in 3.111. So let me show you an example. Okay, so basically we don't just find this y value, because that's not close enough. We find this x value, which is really easy because you just round down or round up, and then we find a y value, and then we find a slope, and then, you know, point slope, make an equation of a line, and then we plug in the original. So let me show you what I mean. So example 1. So estimate, oh sorry, right here. Approximate the tangent line of f of x using, so that's what I said, right? We make a tangent line using x is approximately a. So we don't use a, we use approximately a. So we round down or round up. And then we use that tangent line to find f of a. So here's your example. So we're going to estimate, and you know it's linearization because they say linearization or they'll say linear approximation. Okay, you'll see that linear word. So we're going to estimate this. So instead of plugging this into here, we're going to find a tangent line. Well, how do you find a tangent line using this? The first thing you do is find a slope. And then to find the slope at 2.01, we want to approximate. We don't want to plug in 2.01. We want to plug in a 2, right? So you round down. That's really close to 2. So we get a slope at 2. So we have the slope of the tangent line at 2. All right, and now we take the 2, that 2, and we plug it into the original, and we get a point. So you have a point, and you have a slope. So what do you do with your point and slope? You make your tangent line, which is y minus y1 equals slope times x minus x1, right? And then now you're going to estimate. So now you plug in the 2.01. And you're like, but Ms. Tan, I still have to work with decimals. But you can work with these decimals, I swear. So you're taking the linearization of 2.01. And then what is 2.01 minus 2? So this is exactly the same. I just plugged in 2.01. So when you subtract, you get 0.01. When you multiply, you get, you can do this in your head. You know you can. 0.08. You add 1, and then you get 1.08. So this is, you know, not a wrong answer, but I just want to be really clear. So here what I'm saying is the linearization of 2.01 is 1.08. And the reason I'm writing it this way is because, you know, technically y doesn't equal, like f of 2.01 does not equal this. But 2.01, if I plug it in, is approximately this. And that's what that tells me, that I found the linearization. How close is this to if we plugged in 2.01 into here? It would be that close. That's super close. That really is super close. I put into a calculator, that's what you would get. Okay? So you're like, you know, 2-3 decimal points. Right? So you have a lot of decimal, you have like the hundredths place. I shouldn't say decimal points. You have like the hundredths place. So we're pretty good. So again, you're finding the slope of the tangent line. You're using the easy point to get the y value of the original. And then that's not close enough, right? We don't want to just use 1. We want to do the tangent line and then plug in 2.01. Okay, so one more example because there's only 2 examples. So here's the other one. So let's say you have negative 1.01 and you want to plug it into here. Oh, no, it says linear approximation. Don't plug it in. So using linear approximation, what do? You find a tangent slope at negative 1, and then you plug the negative 1 into here, and you get a point, negative 1 comma negative 10. Now you have a point and a slope. You write your point slope equation. You plug in your actual negative 1.01. You add and get negative 0.01. You multiply, you can do this, and then you get a negative 10 because this, subtraction both sides, and then negative 0.19. And then you add that together, and then you have your final answer. And again, I'm saying as my final answer, so this is okay, but I'm just saying as my final answer, the linearization of negative 1.01 is this much. So I approximated to get this answer. This is not my, f value, my y value, technically. Okay? So there's your example number 2.